Hello everyone and welcome to another video. So in this video let's take a look at these electronic toffees, and these toffees are basically a couple of buck converters. So I bought two of them and they came in this anti-static bag, so that's very nice. They are completely sealed, so let's put one aside. And here is the buck converter. Now buck converter is basically a small electronic module that can convert higher voltages into lower voltages so that you can run a lower voltages devices using a higher voltages. So let's say you have a 12-volt battery and you want to run a 5-volt charger, or you want to charge your phone but you can't do that because your phone doesn't charge at 5 volts. So what you have to do, you will need to convert the 12 volt into 5 volt. A simplest way of doing that would be attaching some resistors in series, but that would cause a lot of loss in terms of heat, and that would make your circuitry very inefficient and your battery will be drained in no time. So we want to be efficient, and we want to also decrease the voltage from a higher voltage source to a lower voltage, while also getting a very high efficiency, and that's when we use a buck converter. So the basic classic working of buck converter is very simple. You've got your input capacitor, your output capacitor, you've got your inductor, you've got your buck IC, and here is your Schottky diode, which will help the inductor, and I will explain in a little bit what it does. So the one that I've got is the LM2596 based, and however on the chip it is written as LM2596S. I haven't checked what the difference between the two is, but I will see that later. So let's take a look at how the buck converter work. So let's say this is your basic circuitry. You have your voltage source, and to that voltage source you've connected a capacitor. And the reason we connect a capacitor is because sometimes the input voltage is very fluctuating. Maybe you are using a solar panel, and as we know, solar panels doesn't give a constant voltage, and so we need to use some kind of capacitor to smooth out the voltage. And to this we will connect a switch that will turn on and off. So this is our switch. To this switch we will connect an inductor. This is our inductor, and to this inductor we will connect another capacitor. This becomes our output capacitor, and to this we will connect our load. So our load is here, and then this connects to there. Okay, so let's take a look at how it works. So if you can see, here is our input capacitor, which is here. Here is our switch, which is built into our IC. Here is our inductor, which is here. Here is our output capacitor, which is this one, and here are our output terminals to which we will connect our load. And here is a small diode, and I will show you why we connect a diode. So let's say we are supplying some voltage. Let's say we are supplying 10 volts. So the 10 volts will come here, and the switch is open, so we will close this switch, and the switch will now connect to here. Once the switch is closed, a current will start flowing through the inductor, and the inductor will get charged. After the inductor is charged, we will get a current. The current will start flowing through the load, and here we will get a 5 volt output. And the capacitor will also charge. It will store charge in forms of the voltage. And the reason we will get 5 volt output is because as soon as the voltage here reaches 5 volt, we will turn off the switch and the voltage will start decreasing. And as soon as the voltage decrease below 4.9, say 5 volt, 4.9 or 4.8 volt, we will again connect the switch. So it keeps on happening. So one time in one cycle we get a voltage of 0 volt when the switch is open. Then we get a voltage of 10 volt when the switch is closed, and at the end we get an average. So average of the two, we will get a 5 volt output. Now when we open the switch, as we know, inductor properties is the inductor cannot instantaneously change its current. So the inductor wants the current to keep on flowing through it, but as we can see, when the switch is open, the current will come here and it has nowhere to go. So what will happen is the current will keep moving in this direction, and a lot of negative charge will start developing here. Negative charge will start developing here. And as we know, according to Ohm's law, because a small current is still flowing in the inductor, Ohm's law says that V equals IR. Now in this case, let's say the current is going to be a little less than 5 volts because the inductor was charged to 5 volt. Let's say it was 4.9 volts or 4.8 volts, and because this switch is open and the current still wants to flow, the resistance here will be taken as an air resistance. So the air basically act as a resistance, and as we know, air has millions of mega ohm of resistance. So millions of mega ohms of mega ohm of resistance times 4.8 will give you a very high voltage, and that high voltage will easily damage our switch or will create a lot of spark that will eventually damage the switch or the component that are used to close the switch. And that's why we need to add something so that the current in the inductor can keep on flowing without having to affect the switch. So that's why we will attach a small diode, and when the switch is closed, in the closed position, the current will start flowing in this direction, and because the diode is reverse biased in this direction, the current will not flow in this direction and the current will flow in this direction, and then it will go like that. Once the switch is open, the current can still flow in this direction, and instead of going here, it will go through the diode because the diode is now forward biased. And this keeps on happening, and we keep on opening and closing the switch so that we get a constant 5 volt output. In this case, we have a feedback circuitry built into the this chip, which takes the output voltage, which is output voltage, and takes a reference voltage and then compare the reference voltage to the output voltage. And if the output voltage is less, then it increases the duty cycle to match the output voltage. If the output voltage is more, then it decreases the duty cycle to match the output voltage. And that is how the basic classic working of buck converter is. So, and this is your very simple diagram: input capacitor, output capacitor, your chip, which also has your switch, and your your feedback circuitry, your Schottky diode, your potentiometer, which will help us to set the output current, and here is your output terminals, here is your input terminal. So that is basic working of buck converters. Now, why I bought these converters? So when I was kid, I would buy a lot of electronic toys, not a lot of them, but the one that I had, when they were broken, I used to take out these motors out of them. And the problem with these motors was that to run these motors you would need at least 3 volt, and all the things that I had were either 12 or 10 volt adapters, or we had to use batteries, and rechargeable batteries were very expensive. They were a thing for VIPs only, and they were so premium that nobody could afford them. So one problem with AA batteries was to attach them. It was very difficult to attach wire to the terminals, so we had to salvage these types of connectors from the toy as well, and then we would connect our batteries to these connectors and then connect our wire, and then use the motor, connect some gears to the motor, use them, or make funny or make a small fan out of the motor. And if we wanted to run some LEDs, we would also need a very low voltage source, and that was also very difficult. So we would use 10 volt, 12 volt adapters, and the LEDs would work for a couple of seconds and then it would completely blow out. So that's why I bought this buck converter, so that I can use a 12 volt supply or my solar panels to change the output voltage to my desired values. So there we go. This was my video on the buck converters. I hope you found this video helpful. Now, disclaimer, I'm not a electronic professional or electronic engineer. However, I did study engineering, electronics engineering for about 2 semesters, but in those 2 semesters they didn't teach us anything about power electronics. So I was interested in this thing, so I kept on researching and I shared what I knew about buck converters. So in the future video we will also take a look at boost converters, talk about them as well, and hopefully I will be able to better explain what boost converters are. And in other future videos we will take a combined approach in which you will get the boost as well as the buck facility in the same module. And speaking of module, the time we live in today is wonderful for electronics. You can almost buy anything in modules and you can make anything at your home. So there we go, this was my video. I hope you found this video helpful. I want to thank you guys for watching, and I will see you guys in my next video. Bye.